Okay, good afternoon, ladies and gentlemen. I'm Max. I'm the CTO of eFormula. Very glad to be here and have this opportunity to share my experience in AI, EMS, and microgrid. The first slide is the introduction of my background and my working experience. I majored in mechanical engineer and got my PhD in 2006. And in 2017, I got my PMP license, and in 2021, I finished my EMBA program, and I'm still fighting for my law school degree now. After graduating from the PhD, I joined E3 for 11 years, and the period of 2012 to 2017, I had been the energy technology staff and the think tank of the Bureau for Energy. In 2017, I left E3 and joined eFormula as the CTO until now. And after I left E3, I still have been the energy technology committee member and several other project leader for government departments. And I also co-work with several energy industrial associations. So in my career, it's about 13 years experience in RD, especially in AI, EMS, and microgrid. Okay, this slide shows what we are and what we do of the eFormula, my company. Our goal is to help our clients reduce their energy emission, carbon emission, and energy cost due to from requirements from the ESG or the supply chain or the government policy. And our core value is use the AI EMS to integrate all the sub-energy systems such as the PV, ESS, or charging station to perform a microgrid. And not only the technology support to our client, but also we have some financial tool to help our client to achieve their energy target, such as the pay-by-saving model or energy-saving insurance. Pay-by-saving model means that if you have very strong energy requirement, but you don't have budget, so we can use the future energy benefit to pay the budget. Okay, that's one. And what's the insurance means that we can achieve energy benefits and performance 100% by the cover of insurance if any accident happens. Okay, so today we'll focus on the technology part. Okay, this slide shows an example of a microgrid architecture, and it's integrated by the low carbon energy and the demand and charging station and ESS. If your energy system don't have the microgrid, means that your power comes from Thai power only, and you will face three major challenges, includes high carbon emission, high energy cost, and very unstable. The first challenge is the high carbon emission. If you use Thai power only, means that your carbon density will be 0.474 kilogram per kilogram hours. The numbers is very huge compared with if you have a net zero target. Okay, so we must use more and more low carbon energy such as PV or natural gas generator. Okay, the second challenge is the high energy cost. As we know that the average electricity price is 4 times than 4 years ago. So we must enhance our energy efficiency and use more and more off-peak energy by ESS. ESS means that energy storage system. The third challenge is the unstable, because our nuclear power plants phase out and more and more renewable energy is going inside to our power grid. So we must have an on-site generator and ESS to enhance the stability of our power system. Okay, so indeed the microgrid can reduce the carbon emission, can reduce your energy cost, and can stabilize your energy system. Moreover, the microgrid can be used as the VPP, virtual power plant, to enhance your energy benefits. And how to optimize and control all sub-energy system at the same time is very important. And today, with the presentation, we'll show some example for you about how to use the AI EMS in a microgrid application. Okay, the first example is how to use the AI EMS to enhance the energy efficiency and at the same time can reduce your carbon emission and reduce your energy cost. And we take the water pump chiller control as the example of a chiller system as example. And other major energy consuming such as the air pressure or the lighting system can be used the same concept as well. So usually the chiller system is designed according to the summer loading in the partial load of 80 to 90% at the maximum energy efficiency. And usually the temperature difference between the inlet and outlet of the chiller is 5 degrees. So it means that if non-summer day, the chiller will operate at low loading with low efficiency. So this is the part we can control operate. Okay, according to the water pump control, there are two major equations we must know. The first one is the flow rate is proportional to the pumping energy consuming cubed. So it means that if we reduce the flow rate, we can get very high energy saving from the pumping power. For example, if we reduce 10% of the flow rate, we can get about 27% energy saving from the pumping power. Okay. The second equation is the heating load is proportional to the multiple results from the flow rate and the temperature difference from the water. Okay, that's the second equation. So we can put the flow meter and the temperature meter between the inlet and outlet of the chiller, and we can using the VFD, variable frequency drive, to control the pump to perform a control loop. Okay, so if we find the water temperature difference below the 5 degrees, it means that we can decrease the pumping flow rate. So from equation 1, we can get a very high energy saving from the pumping result. At the same time, from equation 2, if we reduce the pumping flow rate, so the water difference is increased. So it also means that the chiller system will operate at the low loading to the high loading. So it can enhance the chiller system's efficiency. So usually we use this kind of control loop control can get about 5 to 10% energy saving from this method. Okay, the previous slide only shows the water pumping control, but indeed the whole chiller system also have cooling pump, cooling tower, HU, or even room pump, or even you have more and more chiller system. Okay, so all the equipment should be controlled and optimized at the same time. So we must use the AI fuzzy system to control all of them. So and usually, in my experience, the total control will get about 15% energy saving. Okay, so this is the first example. Okay, the next example is how to use the AI EMS to reduce your energy cost by operating the ESS. Okay, so as we know that compared with 4 years ago, the construction cost of the ESS energy storage system is reduced 40%. Also, the TOU pricing, the time use is 4 times than 4 years ago. So this is very good timing to use the ESS to operate with the TOU and combine with the ancillary service and the demerit response of high power, and it will get very high return. Okay, so for example, this is an industrial customer, and as we know that if we want to operate the ESS, we must match the demand and the TOU pricing and the VPP power policy. So we must use the AI EMS to perform the discharging and charging schedule every day to make sure that we can get the maximum energy benefit. So this is an example of an industrial customer and with the summer day and non-summer day operating schedule. Okay, so ESS schedule. For example, the top figure, the color is different. Okay, the green line is the original demand, and the purple line is the operating of the ESS, and the orange line is the result demand. Okay, the up is the summer, and the below is non-summer. We can see that the operating schedule is totally different due to very complex TOU pricing result. So we must use the AI EMS to dynamically modify all the operating schedule to make according to the high power policy and the marketing price. So we can make sure we can get the maximum energy benefit. Okay. So in this case, it's about almost 7 megawatt hour. The investment IRR is over than 20%. It's a very huge number. Okay. Okay, this is the third example of how to use the AI EMS to enhance the usage of renewable energy and stabilize your power system. And this site is owned by the CPC. CPC is the most big petroleum company in Taiwan. And due to in 2040, the fuel car can't be sold anymore. So the CPC tried to study how to transfer the gas station to the new charging station. Okay. So this is example for CPC. So this picture is a topological transition of all the energy system. We can see that the pink line is the demand, and black line is the demand is the supply from the tide power, and the purple line is the PV output, and the green line is the ESS operation, and the blue line is the charging station. So you can see that in the early morning before the sunrise, the tide power is the only resource to feed the demand. Okay, and after the sun's rise, and the PV increase gradually, and the PV output is more than the demand, so the residual energy can charging the ESS. Okay, so the PV and the ESS will perform a circle. Okay, in this circle, the supply from tide power is almost zero. So you can see in the room is almost RE100. Okay, and after the sunset, the ESS become the only resourcing. Okay, and there's one thing we must know is about the blue line. The blue line is the charging station, and this kind of demand is very violent and random. Okay, however, we can still use the AI EMS to handle this kind of situation. Okay. Okay, this is the conclusion of the above example. So low carbon and low energy cost and the resilience of the grid become more and more important, especially in Taiwan. And the microgrid will be the solution to face this kind of problem. And AI EMS will play a very important role in this kind